Today we're going to talk about how to classify and locate numbers. We're going to spend most of the time discussing how numbers are classified. In elementary, you learned about Venn diagrams, and you see an example. You see on the left-hand side is elementary, the right-hand side is middle school, and in the center is both. It is both because that's where they overlap. So take about 15 seconds or so and turn and talk to your elbow partner and figure out which words should belong in which category, in which section. Five, four, three, two, one. Now that I have your attention back, let's go ahead and classify them. Puppies would definitely be in elementary. Lunch, well, you ate lunch at both. Lockers, well, that is middle school. 6 or 7 classes, that would be also middle school. Bells, technically you had bells in elementary as well to signify the start and end of school. However, bells is more of a middle school thing, but I guess you could classify it as both. I would argue either one, either both or middle school only. But I guess technically they both did have bells. Same thing with tardies. I could argue either one. Tardies are definitely middle school because you have multiple classes. However, you could be tardy to school in elementary. So if you said middle school, I could argue that as well as putting it in both. Learning was definitely both because you learned in middle school as well as elementary. And playground would definitely be an elementary thing, although I think it would be amazing to have a playground in middle school as well, because I think we sure all need it. Here's another example of a Venn diagram, but using math. So we have something called natural numbers and whole numbers. Whole numbers are exactly what they mean, whole numbers, that they do not have decimals or fractions or anything like that included in it. But natural numbers are very, very similar. The way I like to think about it is natural numbers, when you started to count as a toddler, you naturally started counting at 1. If your mom or dad or whoever held up 3 pieces of candy and told you to count them, you would count 1, 2, 3. Therefore, natural numbers are all the numbers like 1, 2, 3, and so on, forever and ever. Whole numbers are the exact same thing as natural, except the one and only difference a whole number has is now the number 0. So as a toddler, you learned to count with 1, 2, 3, and so on. And then as you got a little older, you learned about the concept of nothing, of 0. So if I look at this, 1 would be a natural number, but it also is a whole number because there's no fraction or decimal associated with it. 7, same thing. 3, 25, even though there's a dollar sign, doesn't matter. 25 is still a whole number. 0 is not natural, however, so 0 is my whole number, because remember, natural is only 1, 2, 3, 4, 5, and so on. 5 is both, 100 is both, and 2 would be both. So notice every single number in this natural number circle also belonged inside of this whole number circle right here. So every natural number is also a whole number. The only thing that sets whole numbers different is that whole numbers now include the number 0. Now, Venn diagrams can also look similar to this. This is an example of a nested diagram. Well, we have our middle school in the very center, which is Kayla. And then Kayla is located inside of Houston, which is located inside of Texas, which is located inside the USA. So if I asked you, is Kayla inside of Texas? Well, you would say yes, because if I draw my circle around Texas here, is Kayla inside of that circle? Yes. Now, if I asked you, is Houston inside of Kayla, inside of our middle school? Well, if I circle our middle school, is all of Houston inside of that orange circle? Well, no. So does Kayla encompass all of Houston? No, because there are many, many other middle schools in Houston. Kayla is not the only one. So it's you got to make sure you understand how to read these. If I said, is Houston inside the United States? Well, if I circled the United States or USA, is Houston inside of this blue circle? Yes, therefore, it is part of the US. Now, let's take a moment and watch this video.
Hi, welcome to Math Hands. In this lesson, we're going to learn about negative numbers. Negative numbers can be a little confusing at first. Don't get concerned, it takes a while to get to. To learn what negative numbers are, we first need to start with whole numbers. You remember what whole numbers are, right? They're the set of numbers on the number line, starting with 0 and then counting up one at a time, 1, 2, 3, 4, all the way to infinity. That's a lot of numbers, but it's only half the story. And that's because the number line really goes in both directions. You're used to seeing the number line starting at 0 and just going to the right, but the number line also goes to the left. And what numbers are on that part of the number line? Yep, you guessed it, negative numbers. The negative numbers are just like a mirror image of the numbers on the right side of the number line that we call the positive numbers. And 0 is the special number that separates the positive numbers from the negative numbers. By the way, when you combine all these numbers, 1, 2, 3, and so on up to infinity, -1, -2, -3, and so on, down to negative infinity, and the number 0, that entire set of numbers gets a special name in math. They're called the integers. As you can see, the negative numbers look just like the positive numbers. The only difference is that they have a negative sign in front of them.
Okay, so if I talk about what an integer is, if I looked at this number, -1.5, is it an integer? Why or why not? Why don't you take about 15 seconds or so and turn and talk to your elbow partner and say yes or no and give an explanation as to why. Five, 4, 3, 2, 1. Now that I hopefully have your attention back, let's discuss it. So in the video, he said negative or integers were all the positive whole numbers and all the negative whole numbers, or he worded it as all of the positive whole numbers and its opposite. So if I put negative 1.5 on this number line, here's negative 1, so 1.5 would be right here. Is it an integer? Well, the answer is no. And the reason behind it is it has a decimal. Integers are only whole numbers. Now, if it said negative 1.0, is that an integer? That answer would be yes, because this 0 you can drop off and just say negative 1. So integers are all positive and negative whole numbers only. Now, all of these numbers are part of what we call the rational numbers. Rational numbers include all integers, we just talked about that. It includes all whole numbers, and it includes all natural numbers. Okay, now integers also, rational numbers also include all fractions and in most decimals. I didn't include all of it, just most decimals. So they're decimals that terminate. Terminate means to end. For example, 0.75, 75 hundredths. It ends, it does not go on forever and ever and ever. It also includes repeating decimals, such as 3/10 repeating, which is 1/3. Repeating decimals repeat the same number forever and ever. And I talk about that because in 7th grade, you will learn about another type of number, and that would include the decimals that never ever end, but never repeat. So that is something for 7th grade. This year, we're focusing on rational numbers, which are terminating decimals, or decimals that stop, and repeating decimals, such as 0.3 repeating, that repeats the same number. Now, if we look at this Venn diagram, you can see that we have natural numbers in the center. So every single rational number on here, or every single natural number, is a rational number. Because if I circle my rational circle, then natural is inside of it. So it's very, very important to look at how we read this. Remember, on the previous slide, we said that this was Kayla, this was Houston. Oh, if I can spell Houston. Integers was Texas, and rational was the United States of America, USA. So if that analogy, using our school and our state and all of that, if that helps you, label it. Every time you see these words, label it with Kayla, Houston, Texas, US, and see if that helps you. I know sometimes it can get really confusing talking about all these different type of numbers. So if putting it into more simpler terms that you understand help, please by all means use it. Now this should have been glued, or you should be gluing it right now into your notebook. If you need to still glue it in, pause the video, get it glued in, and then press play again. Now the number 5, once it's written as a fraction, well, you should remember from elementary, we can write every whole number over 1 to make it a fraction. Now, I'm going to start over here at natural. Remember, natural was Kayla. Whole numbers was Houston. Integers was Texas. Rational was the United States. Now, as a toddler, can I start counting at 5? Or can I count to 5? 1, 2, 3, 4, 5. The answer is yes, so therefore it is a natural number. And if you refer back to the previous slide, you can see that natural numbers are inside the whole number circle. Therefore, natural numbers are whole numbers. It's inside the big integer circle. So you can see that natural numbers are integers, and it's inside the rational circle. so therefore they are rational as well. So all of these should be checked. Then 1.5, written as a fraction, and the fraction is a over b, so it wants it as just numerator, denominator, no whole number. So if you recall from earlier this week or last week, y'all learned something called Texas. And if you didn't, pay attention, because this is how you convert all mixed numbers into improper. So just like the song that Drake sings, we started from the bottom. We start from the bottom. 2 times 1 is 2, plus 1 is 3, and my denominator stays the same. Now, if you're 3 years old, are you going to be able to count 1.5? Probably not, unless you're a child genius. So it's not going to be a natural number. Now, is 1.5 a whole number? No, because it has a fraction, therefore it is not a whole number. Is 1.5 an integer? Remember, integers were positive and negative whole numbers. So if it's not a whole number, it cannot be an integer because it's not a whole number. So therefore, it has to be rational, because remember, rational included all fractions. -5/10. Well, we need to write it as a fraction. The negative sign stays. 5/10. Well, I can put 5 over 10, but we simplify it to be 1/2. Again, that's a fraction. Are fractions natural numbers? No. Are they whole numbers? No. Are they integers? No. Now be careful on that one. Just because it has a negative does not make it an integer. Negatives do classify under integers, but only when it's a whole number. This is a fraction, therefore it is rational only. -3, well, we can write -3 over 1. As a toddler, you can count to 3, but do you have any idea about negatives? Probably not. So, definitely not natural. Whole number, yes, it's a whole number, but it's negative, so it's not classified there. Negatives do not show up until integers. And it's a whole, 3 is a whole number, so therefore it's an integer. And if it's an integer, it is also rational. You should start kind of seeing a pattern with the rational numbers at this point. All right, the next one is 0. We can write it as a fraction as 0 over any number. 0 can be written on top of any number, and it's always going to simplify to 0. Now, at 2 years old, does a 2-year-old know what 0 means? If I held up 3 markers in front of them, they're going to start counting at 1, not 0. So therefore, 0 is not natural. 0 does show up, however, in the whole numbers. And if it's a whole number, it's also an integer. And if it's an integer, it's also rational. Because if I reference back up here to the top, if I'm in Houston, I'm also in Texas, and I'm also in the United States. All right, 17.0. Well, remember I said before that 0.0 I can drop off. So we can just rewrite that as 17 or 17 over 1. Now at 2 or 3 years old, a kid probably cannot count all the way to 17. However, it can be done. It is a natural number. Now, remember, that means I'm at Kayla. Is Kayla in Houston? Yes, so natural number is also a whole number. Is Houston inside of Texas? Yep, so whole numbers are integers. And is Texas inside of the US? Yep, so therefore integers are also rational. All right, and the last one, 7/5. Well, it's already written how it won it, so 7/5. But if I were to rewrite it as a mixed number, I would divide it out. Remember the movie Inside Out? So we go inside out, and you would divide and end up getting 1 2/5. Again, that's a fraction. Where do fractions show up for the first time only? Fractions show up in rational. Fractions are not natural, they're not whole number by definition, and they are not integers. Now here is just another example. Instead of saying Kayla, Houston, Texas, US, we could talk about animals. So I could have specifically a Yorkie, a type of dog. So a Yorkie, which is a dog, which is a pet, which is an animal. And these words can be interchanged with just about anything you want. So I could even be specific and say a crayon, which is a color, or we can say crayon marker even, which is a color, which is a writing utensil, which is something else. Y'all can kind of fill in the blanks. So tons of different ways I could interchange all of that. Again, here's my thing from earlier, my different types of numbers. And then we just filled this thing out. And so now we're going to look at it, we're going to look at it using my Venn diagram. And we're just going to go through this really quickly. Now, if I start with the first one, 3, where does the number 3 show up for the first time only? 3 is a natural number, so we're going to put 3 in the natural numbers. Now, is 3 also in this whole number circle? Yes. So is 3 also a whole number? Yes. However, we're not going to write 3 in every one of these because then it just gets way too crowded. So we're only putting the number where you see it for the very first time only. All right, negative 52.7. Well, that's a decimal. So where do decimals show up? Good, it's rational. Even though it's negative, and that's an integer, it has a decimal, because remember, integers are whole numbers only. Negative 23. Good, integer. Negative 5. Good. 2 7/9. Where did fractions show up? Good, rational numbers. What about 0? Whole numbers. Here's a little trick to remember that it's a whole number. Do you see the 0 in that word whole? Whole numbers. You should see the 0 inside that word whole. All right, 12.0. This is a tricky one. That should be natural numbers, because remember, I can drop off that 0 and it just becomes a 12. Negative 14. That is an integer because it is a whole number, no fraction or decimal. 5/2. Now, if I simplified that, what would 5/2 equal? Good, 2.5. So where would that show up? Good, rational. What if I simplified negative 6/3? So that really means 6 divided by 3, which is 2, and there's a negative, so I got to put the negative. Now, Even though it's written as a fraction, notice it simplifies to something that's not a fraction. So -2, where would that fall? Good, that would actually fall in the integers because -2 is whole and it's negative, which means integers. Even though it's written as a fraction, like I said, it simplifies down. If it simplifies down, it does not automatically get put in rational. It gets put wherever the simplified form is. So simplified, it's an integer. So unsimplified, it is still an integer. And the last one, 110, that would be a counting number. Now, at this point, you will have the remainder of class to make sure you have all of this in your ISN filled out correctly. And tomorrow when you get to class, we are going to work on resetting some passwords, as well as working on an independent practice covering this. So it is very important that you have paid attention and you have taken good notes, because this is something really great to reference back to. Make sure you ask your teacher if you have any questions or if there's anything you don't understand, because we are unable to help you if you do not ask for help. So make sure you are asking.